Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel. We're here to help you, help you approach SAT math questions. This is Math Question 8. It's a little obliterated there, but it's from a set of practice questions that the SAT put on their pamphlet related to the digital SAT, which is starting in the United States for high school seniors in the spring of 2024. Okay, here we go. Function h is defined by this thing, okay, where a and b are positive constants. The graph of the y is equal to h of x in the xy plane passes through the points 0, 10, and negative 2, 3, 25, 36. What is the value of a times b?
Uh-oh.
Wow. Oh, this is certainly not a 2-second question.
Wow. I know. It's right out the math.
Wow. Look at this
Maybe
question.
A 2-minute question.
Look at this.
So just do the math.
Well,
Set up two equations and two unknowns. Don't bother graphing it.
Well, I have to graph it. Which means that when x is 0, this thing is 1 plus b.
Yeah.
Well, look. Oh, they got the... Wait, that tells you b. No, wait, does it? 1 plus b equals 10. So b is 9.
Yeah. Okay.
Wow, we got that pretty fast.
Yeah.
Right? Am I right?
Right.
I think so. Because you see, if we put a 0 in here, anything to the 0 power is 1.
Yeah.
1 plus b is 10. Wow, b is 9. So that means all we have to do is get a.
Yeah.
Wow, though that was a pretty easy Sec2 equation to run. See, Seth, graphing did help. Okay.
Yeah.
Now, what about this negative 2 thing? Oh, negative 2 thing means that... Oh, so it's pretty high. This makes sense. At negative 2, it's about 10. No. Yeah, no, it's less than 10.
Well, we don't really know what A is. We don't know if it's curving up or down.
Oh, you're right.
Because we don't assume A might even be negative.
No, and they say A is positive.
Oh, okay.
Yeah, so the negative 2
I would just write out the math.
Yeah, okay, fine. So, 3, now there must be a pattern that makes this easy, because they wouldn't put some weirdo number like this.
It's 30. You go 36 is equal to...
Okay, now it's a...
1 over a squared, or a to the minus 2.
A to the minus 2, plus... Yeah. I'm just trying to be careful. Now, this is a calculator test, so I'm lazy. So let's just do that. 325 divided by 36. Oh, God. No, that's not... Wow. Oh, my God. Equals... Wow. 9.02777777. So they really don't want you to use a calculator, because we have to convert... Oh, I guess we can do that. We have to convert this decimal 0.0277778 to a... This is equal to 9.0277778. So does that mean that 1 over a squared equals this thing, 0.0277778 reciprocal, 0.0277778? Wait, 0.02777.
All right, go ahead.
Okay, fine. Okay, this is a squared, right? Right out to calculator. 36. Okay, this is equal to 36. Okay, sorry. This is 1 over a squared is equal to 36. Right?
Okay. So there you're solving for A.
This is 1/6.
They subtract 9.
No, we're done with that. No, you're done with that. So they this means that 37. That means that a squared is 1 over 36, so a is a sixth. Oh my god.
Okay.
Oh, so okay, so it's 9 times a sixth. I could do that. 9 times a sixth is 9 times a sixth is 1.5. There's no answer for 1.5.
Uh-oh.
Oh my god. 325 divided by 36 is 9.0 do. So you subtract 9 on both sides. You get 1 over a squared is 0.0. I did something wrong. This is 0.0277778. Oh, so that means that the square root of a... God, I'm really blowing us. Oh. A squared doesn't help, the screen froze. A squared is 1 over that. So you want to take the square root of that and then take the reciprocal. Okay? So a squared... Yeah. But, I think we may have to get another application because this is crazy. A squared is 1 over this crazy thing, right? Which means that you want to take 1 divided by 0.0277778 and then take the square root of that and get 6. What's going on? Seth, help me.
Well, let's see. Let's check it one little at a time. So -2. So this is the equation. The one, when an x is equal to 0.
No, I made a mistake.
H is 10.
No, a is 6. What am I doing? A is 6. It's too many fractions going on. A is 6, not a sixth.
So what? B is 9 and A is 6.
Yeah, I made a mistake. So I gotta go slower. Okay? I gotta go slower. 1 over a squared is this crazy number. Okay? 1 over a squared is this crazy number. Okay? Right?
Right.
Now let's do it slowly. Now what is this crazy number? This crazy number is 1 over 36.
Okay. So a is a 6. Is 6. A is 6.
1 divided by 36 is that crazy number. A is 6. Okay. So that is shocking. Absolutely shocking that they did not put 9. They did not put 1.5 on there.
Well. So it's a calculator question.
Yeah. Wow, I really blew that. Now, let me be completely honest. When I looked at the answers and I moved up like this, I remembered the answer was C. That's how I knew so fast that I was wrong. I totally cheated on this question, okay? I saw the answer and I said, oh, A is 6, and then I realized my mistake. That's completely cheating, but, I have to be honest about it.
Well, so what's the approach?
Try to be
with really problems neat. Like this.
Be neat. Be careful and neat. And don't do things I always say you shouldn't do, which is to sort of like let your eye do it. Don't let your brain go faster than the paper. I did it here. You could see. Everyone could watch the video. I totally blew it. Got to be neat and organized. God. What do you think?
Yeah. Well, you got yourself your 1 over a squared equals 0.027.
That's right.
You did write it down.
Yeah, I did. But then I cut corners. I started doing it in my head.
And then you took the reciprocal of both sides. And what's this garbage here?
I'm trying to erase the garbage.
I circled it in red.
Yeah. I'm trying to erase it.
That barely looks like numbers.
Yeah.
Yeah. So don't write garbage.
Yeah, I was trying to do too many things in my head. I was trying to take the reciprocal of this, and then you have the reciprocal of this.
Oh, you just went off the cliff. There's just one misstep. You have it all. You had it all here.
Yeah.
And then you're right. Certainly you take the reciprocal of both sides, get a squared equals, and then, okay.
Wow.
So you used your calculator to see that, 0.027778 was 1/36.
That's right. I did.
Okay.
I did.
Okay. Now let's see what the SAT, what's the College Board's explanation is.
Yeah. Okay. I bet they got the 9 pretty fast. Advanced math. Woo, look at that. Make connections to algebraic representations and a graph. Ooh, look at that. See, they talked about the graph. Oh, we looked at another answer. I hate that. I hate when everything's like next to each other. Okay. Substituting 0 for x and 10 in the equation yields 9. Okay, so we did that. That's good, right? We're right on track. Substituting -2 yields this equation. Subtracting 9 yields this, which we did. Right, you see, so converting to decimals was a mistake. Yeah, fractions are your friend. Fractions are your friend.
You should have divided.
No,
you should have divided integral.
No, I should have done fractions. I should have done 325/36 minus 9 times 36.
Minus 9.
9 times 36 is 324 over 36. I shouldn't have converted to decimal. That was my mistake. I should have
But the converting to decimal worked.
No, it didn't, but I wouldn't have made the mistake if I did fractions. If I did...
I don't know. Maybe you would.
Of course I wouldn't have. Because it would have been this. 325 divided by 36 minus 9 is equal to 325 over 36 minus... Now, 9 times 36 is easy. 9 times 36 is 324 over 36. So that's clearly 1 over 36 is equal to 1 over a squared.
Well,
and then clearly a. So, I always have this little thing. Fractions are your friend.
Yeah. But you could also, could use a calculator or by hand divide 36 into 325.
Right.
And yet what you're going to get is 9 and a 36th.
That's right. Yes.
So you could do that without a calculator, or using.
Wait.
Yeah, well, you with a integral calculator, you get like a remainder of 1, right?
No, but wait, if you did a calculator, you would get 9. You would get 0.022777777.
Well, if you do 36 into, what was it? 325.
Yeah.
9 times 6 is 54. Carry the 5. 9 times 3 is 27, 32. Remainder of 1. And so,
wait, who has a calculator that does that?
9 and 1/36.
Who has a calculator that does that?
My mind and hand.
Mind what?
My mind and my hand and my pencil.
But very few people are going to be doing that.
Yeah.
So yeah, I mean, it looks like going into fractions, doing this, in fractions probably made the Seth hates when I do that. 325 over 36 minus 9, and then you do a common denominator.
Yeah. Okay, so they don't explain how don't make it shrink.
Okay.
They don't explain how they did the arithmetic to get 1/36.
That's right. They don't. That's the key to the problem.
Yeah, that's the key to the problem.
Yeah.
Like you know that 9.
Yeah.
Yeah.
So one thing that's fundamental to this problem is you have to know that when you are given points that go through a equation, then where is the equation anyway? Where is the problem? Anyway, I don't even know where it is.
Well, you could think of it both. You could say, you're thinking about it graphically. You're thinking about it graphically, but you could think of it, purely algebraically. It's 2 equations and 2 unknowns.
Yeah, but you also have to know the big concept that if you have a graph and you have a point, the XY has to satisfy the equation.
Oh, yeah.
That is absolutely critical.
Well, they talk about it. They give you they give you the data in terms of a graph. That's right. So you have to convert the data expressed in terms of something in a graph to data expressed in algebra. Yeah. Well, I don't know. Maybe a hindsight piece of insight is, let's see, we're interested in 325 divided by 36 minus 9.
Yeah.
Now, well, you could think of this as, 325 is it's a bit less. It's 11, right?
Yeah.
It's somewhat less than 360.
Absolutely.
And so we perhaps compare. So the insight would come from comparing 36 times 9. Compare that to 325.
Yeah.
Now 36 times 9 is 360 minus 36.
Yeah, but if people have a calculator, you're going to do 34.
Yeah. So
it's 324.
That's 324. And then as soon as you calculate 300, so as soon as you calculate 36 by 9, you get 324, and 324 compared with 325, there's only one difference.
Right. Yeah. So it's 1/36.
Yeah. So your idea of converting this, of simplifying this, you started writing out, this is equal to 325 minus 9 times 36.
No, I didn't do any of that, Seth. Look at what I wrote.
Over the denominator of 36.
Seth, can you please look at what I wrote? Look at what I wrote, which I think, frankly, was pretty good, pretty insightful. Yeah. Look at this. Look at what I wrote. I went into decimal, and I made this observation. Yeah. It was clear that A to them, these 9s cancel. You see, you have a 9 and a 9.02 junk.
Yeah.
So immediately, 1/a² is the junk. Oh, by the way, you also have to know about negative exponents. We didn't even talk about that. In order to do this problem, you got to know about a negative exponent, which is some people may forget or not even know that a negative exponent is an instruction to put whatever is being negative exponented. What is the word, Seth? Negative x. What is the verb?
Exponent.
Whatever has the negative
exponent.
No, whatever has the negative exponent has to be flipped. Has to be, if it's in the numerator, you have a negative exponent in the numerator, like 3 to the negative 2. That means that it's 1/3². The negative exponent is an instruction to whatever it's in the numerator, put in the denominator. Whatever in the denominator, put in the numerator. So you have to know that. Also in this problem, we skipped over that. That's not necessarily an approach, but that's a piece of knowledge that you need to know.
Yeah, well, you said so. It's substituting a negative number, -2, -2, for the x in the expression a to the x plus b.
But then you have to know what that means when you
notice I very carefully wrote the negative. Don't flip it around.
I have to, otherwise people won't see your writing.
-2 is carefully enclosed in parentheses so that the whole of -2 is the exponent of a.
Right.
I did not write like that.
Okay. Most people would write that, but that's fine. Yeah, but the bottom line is the negative exponent means you got to put it in the denominator. Without knowing that,
it depends what we're going to do with it. But that's true. Yeah, the whole point is, in general, p raised to the -q power is equal to the reciprocal of p to the qth power.
Right.
No matter, okay.
Yeah. Okay, so I guess that's it, right? I know I made a few mistakes. That was really bad. I'm shocked, just totally shocked. And I really lucked out big time that the 3/2 was not part of the answer here. I'm very lucky. If I didn't see the answer C, trust me, in about 30, 40 seconds, I would have realized the mistake.
Yeah.
But I was you are so lucky on a multiple choice test if you get the answer that's not an answer that's on the test. Yeah. Really lucky. Really lucky.
I wonder if... Oh, okay. You need to find A. Yeah, so... right. So, okay.
It's a blessing when you answer a question wrong on a multiple choice test, and they don't think that anyone in their imagination could have answered it that wrong.
Well, It's even more of a blessing when you get it right the first time.
Well, yeah. No, but if you get it right the first time, you're not necessarily sure you're right. For example, if 3/2 was an answer, I would have said 3/2 and I would have gotten it wrong.
Oh.
So it's better. Obviously, it's better to get the answer right the first time.
Okay. I think we're done with this.
We are really done with this.
Yeah.
Okay, everyone. Have a great day.
Happy Tuesday.
And you too. Bye-bye, everyone.